Hello. This nugget is part one of a three-part series that will cover the basics of how a computer works. And this part will provide an overview of the core components of a computer, and these are the CPU, RAM, and the motherboard, aka system board. Part two will cover the boot process of a computer, and part three will cover programming. So the CPU, or central processing unit, it executes instructions, which are commands that the CPU is designed to be able to execute. And there's a limited set of instructions that each CPU is designed to understand, and that set is called the instruction set. Instructions are fairly simple. For example, an instruction might be add two numbers, or subtract two numbers, or write some data from the CPU into RAM, or get some data out of RAM and put it in the CPU so the CPU can perform a computation on it. The CPU can keep track of only a very small amount of data at one time, so it uses RAM, which is called main memory, to keep track of the large amounts of data that the CPU will need to compute or process. You may be thinking, how can a computer or a CPU that only understands simple instructions such as add and subtract be able to do things like land an airplane or drive a car without human intervention? The answer to that question will be covered in part three, but for now we will continue on with the CPU. The CPU has two main subcomponents. The first is called the control unit, which figures out how to get instructions to execute and figures out how to get those executed. And the second is the arithmetic logical unit, which does the actual computations or calculations that need to be done. The control unit and the ALU both have a very small amount of memory cells called registers. Most instructions will tell the CPU to do something with data in those registers. For example, a possible instruction may be to take the two numbers that are in register 5 and 6, add those two numbers together, and store the result in register 7. So now you may be thinking, well, where did the data values in registers 5 and 6 come from, and how did the CPU know to add those together? And here's where RAM comes into play. RAM is used to store the instructions that the CPU will need to execute, as well as the data that the CPU will need to process. RAM makes no distinction between data and instructions, because to RAM is just all bits that it needs to remember. So how do those instructions and data get into RAM? That question will be answered in part two. RAM consists of a number of memory cells. Each memory cell has a unique label or address, and each memory cell can remember a certain amount of data. Now the acronym RAM stands for Random Access Memory, and random access means that it will take the computer approximately the same amount of time to get data out of any arbitrary memory cell in RAM, or put data into any arbitrary memory cell in RAM. So here's an analogy. Imagine that there is a warehouse of storage units. Each storage unit is the same size. Each storage unit also has a unique label, and each storage unit can store some data or a number. Now imagine there's a worker monkey that sits out in the front of the warehouse and waits for data requests. One type of request is to find out what number is stored inside a particular storage unit. This type of request is called a read. Another type of request is to put a particular number value in a particular storage unit, and this request is called a write. And the worker monkey is an analogy for the computer component called the memory controller. So now I'll cover how the CPU gets instructions and data from RAM. The CPU constantly repeats a cycle known as the instruction cycle. And the phases of this cycle are to fetch an instruction from RAM, interpret or decode what that instruction means, what it tells the CPU to do, to actually execute that instruction, and the last phase is the increment. It means get to the next instruction that the CPU will need to execute. So let's talk a little bit about the fetch phase. There's a special register inside the control unit called the program counter, or the PC register. The PC register stores the memory address that contains the instruction, the next instruction that the CPU will need to execute. Now during the fetch phase, the CPU asks RAM to get the instruction that's stored in the address of the PC register and put that address in another special register called the instruction register. So now the actual data that represents the instruction is inside of the control unit in the instruction register. Now during the interpret or decode phase, the control unit will decode the instruction to figure out what it's supposed to do. So some instructions will cause the ALU to perform a calculation, or some instructions can be handled by the control unit, and these deal with writing data to RAM or reading data to RAM, or possibly writing data to a disk or reading data to a disk, or communicating with other input-output devices. Now, during the execute phase is when the instruction actually gets executed. During the increment phase, the address stored in the PC register will increment, which means increase by 1. And when the CPU starts the next cycle with the fetch phase, it will use the new memory address to get the next instruction that it will need to execute. So there's an overview of the CPU and RAM. Now we'll talk about the system board, which provides the system bus, and that's a data communication channel where the CPU, RAM, and other input-output devices, peripheral devices such as a hard disk or keyboard or mouse or a video card for a monitor plugs in. They all plug into the system board, and they can all communicate primarily with, most importantly, with the CPU. So that's the end of this part. And then the next part, part 2, I'll talk about the boot process, which covers just how does instructions and data get into RAM, and how does the operating system get loaded into RAM, or how does the computer boot up so it actually can run. So thank you. Hopefully this was helpful, and take care. And the most common way is to use a username. You have to type a username and then